A. To prepare mixture and a compound using iron filling and sulfur powder. B. To distinguish between the mixture and compound on the basis of appearance, that is, homogeneity and heterogeneity. Behavior towards a magnet, behavior towards carbon disulfide as solvent, effect of heat. Materials required: iron fillings 10 gram, sulfur 6 gram, carbon disulfide, dilute hydrochloric acid, lead acetate, 2 watch glasses, a magnet, a china dish, a glass rod, 2 test tubes, beaker, burner, tripod stand, wire gauge and magnifying glass. Theory: substances combine and undergo changes. The changes can be broadly classified into 2 categories: physical changes, chemical changes. Physical changes: changes in which the original components do not change their properties, there is formation of no new substance or compound, are called physical changes. For example, dissolution of sugar in water, where sugar does not lose its property of sweetness before or after formation of sugar solution. Chemical changes: changes in which original constituents undergo change to form a new substance or compound with entirely changed properties are called chemical changes. For example, burning of coal where carbon combines with oxygen to produce carbon dioxide, carbon monoxide and energy in the form of gases. 4C plus 3O2 gives 2CO2 plus 2CO plus E. Carbon plus oxygen gives carbon dioxide plus carbon monoxide plus energy. In this case, carbon dioxide and carbon monoxide have properties entirely different than carbon and oxygen. Moreover, carbon and oxygen from carbon dioxide and carbon monoxide cannot be recovered easily. Mixture is a substance containing 2 or more elements or compounds in any proportion. Compound is formed by the chemical combination of elements in fixed proportions, while mixture involves a physical change only. The components of a mixture retain their individual properties, while the constituents of a compound lose their identity, so the components of a mixture can be separated by using physical methods. By using magnet, iron can be separated from iron and sulfur mixture. Mixture is heterogeneous while compound is homogeneous in nature. It can be tested by using magnifying glass. Procedure: 1. Preparation of mixture of iron and sulfur. Take 10 gram of iron fillings and 6 gram of sulfur and put them in pestle and mortar. Grind the constituents properly. By this process we obtain the mixture of iron and sulfur. Now transfer the mixture in a beaker and mix them properly. Label it mixture A. 2. Preparation of compound iron sulfide or FeS. Transfer half the mixture in a china dish. Heat the mixture strongly on a burner. Stir the constituents continuously by a glass rod. When a black mass is formed in the china dish, transfer the compound formed into the pestle and mortar. Grind the constituents properly. Now, transfer the powdered iron sulfide compound into the watch glass. Label it compound B. Iron plus sulfur on heating gives iron sulfide. Observations, properties, experiment, observation, inference. 1. Appearance. A. Place a small quantity of system A on a watch glass and stir it with a glass rod. B. Place a small quantity of black mass B on a watch glass and stir it with a glass rod. Particles of iron filling and yellow sulfur are seen by naked eye. Each portion of the black mass has the same appearance. The mixture obtained on mixing iron filling and sulfur at room temperature is heterogeneous. The compound iron sulfide obtained on strongly heating iron fillings with sulfur is homogeneous. 2. Test with a magnet. A. Move the magnet over mixture A. B. Move the magnet over compound B. Iron particles cling to the magnet. Iron particles are not attracted. Iron retains its properties in the mixture. Iron has lost its properties in the compound. 3. Behavior towards carbon disulfide. A. Place a small amount of mixture A in the test tube. Add carbon disulfide. Shake well. B. Place a small amount of compound B in the test tube. Add carbon disulfide. Shake well. Yellow particles of sulfur dissolve and black particles of iron settle. There is no change in the test tube. Mixture can be separated into constituents by the physical methods. Constituents of compound can separate out. 4. Effect of heat. A. Take a small portion of mixture A in a china dish and heat it strongly. B. Take a small portion of black mass B in a china dish and heat it strongly. A black mass is formed which does not show the individual properties of iron and sulfur. No change is observed. When the mixture is heated strongly, iron and sulfur lose their individual properties. Iron sulfide does not lose its properties when it is heated. Results: 1. Mixing of iron and sulfur results the formation of a mixture. If this mixture is heated, a chemical change takes place and a compound iron sulfide is formed. 2. Mixture is heterogeneous while compound is formed. 3. The properties of iron sulfide compound are quite different from the properties of its constituents. Precautions: 1. Heating of mixture of iron and sulfur must be done in the china dish or hard glass tube. 2. Heating of mixture of iron and sulfur should be done very carefully. 3. Minimum amount of the mixture and compound should be used for testing. 4. Hydrogen sulfide gas should not be inhaled. Some important facts: 1. Extremely flammable liquids have a flash point less than 0 degrees Celsius and a boiling point less than or equal to 35 degrees Celsius. 2. Radioactive substances are those which emit dangerous or harmful radiations and present a serious risk of acute or chronic poisoning by inhalation, ingestion, or skin absorption. 3. Corrosive substances destroys living tissues.